Okay, so now we're going to go and do another example, solving with common logs, similar to the one we just went through. So it'll go through a little faster. So let's say example 2, common logs. On this one, I will show you how you can use your calculator to check and make sure that your answer is correct. So that's pretty handy. Let's see, how about 6 to the x? 6 to the x equals, I don't know, 52. 6 to the x equals 52. All right. And your instructions would be something just like solve and round. Okay, solve. All right, 6 to the x equals 52. Well, we don't know. 6 squared is 36. 6 to the third power is 256, I think. I should know that one. Let's look. 6 to the third. Oops, 6 to the third. 216. Sorry. Error. Anyway, so a little more than 2 because 52 is closer to 36 than it is 216. So how did we work this in the past? Well, we said, can we rewrite in the same base? Can we rewrite 52 using base 6? No, we can't. We don't know what that is. It's 2 and some change, right? We don't know. All right, so we can't do that. Can we rewrite in log form and say log base 6 of 52 equals x? No, we can't, because we don't know what base 6 of 52 is. So that doesn't help us. So what can we do? Well, we can use the log property of equality and just logify both sides. All right? Using the log property of equality. And so what will we have? So now we will have log. And again, this is understood base 10, all right? So we don't have to worry about some base. Understood base 10. So log of 6 to the x equals log of 52. Understood base 10. Understood base 10. I have a power rule, so I can bring my x out, because that's what I'm trying to isolate x, so I can actually solve for x. So because of the power rule, we will bring him out. And I now have x times the log of 6 equals the log of 52. To solve for this x, I will divide both sides by log of 6. So we will use the property of division. Log 6 divided by the log of 6. Log of 6 divided by the log of 6 is 1 times x is x. And now I'm going to use my calculator. The log of 52, close parentheses, divided by the log of 6. And again, it's very important that you close your parentheses, then hit divide, then do log of 6, then close your parentheses, right? So on your calculator, let's see, log of 52, close parentheses, divided by log of 6, close parentheses. Again, okay, it's very important that you close out the argument before you hit the division sign. And I hit enter, and this is what my calculator says. And I will round it. So we're going to say x is approximately 2.205, and then it's 23. And we've rounded. We don't want to round very much. And when you round in logs, you really skew things. So that's why we're taking it 5 places past the decimal. This is the correct answer. But I want to show you that you can use your calculator to check this. So what I'm going to do is somewhere back here, I have my calculator app. So let me get it up. We are looking to see if in fact it is 2.20523. So I'm going to pull this up. That's not what I want. Let's see. Hang on. Aha, here we go. So go to your original equation that we had, which was 6 to the x equals 52. And I had showed you in class before the break that you can use your calculator to check any equation. And you will put the left side of the calculator in y1, the left side of the equation in y1 and the right side of the equation in y2. So on the left side of the equation, we had 6 to the x. So I'm just going to type in 6 to the x. And then on the right side of the equation, we had 52. So I'm going to type in 52. And we were going to look at the graph and see where they intersect. The x value where those intersect better be the same value we just found, 2.2 whatever and change. So you probably are going to have to adjust your window so that you can see the y value of 52. Let me look at my window. Yeah, look at here. My y max is at 15. I know I'm going to need to see above 52. So I'll just type in 60 right there. And hit graph. And there's my exponential. And there is 52. So this is the graph of 6 to the x. And this is the graph of 52. And this point right here better be 2 and some change. So let's go through how we find that point of intersection. Second, calculate intersection, number 5. So just hit the number 5. And this is our first curve, enter. This is our second curve that we want, enter. And we are guessing that it's 2.2 and some change. So I'm going to hit enter one more time. And shazam, 2.2052311. All right, 2.2052311. Let's look and see. Let's look and see. Where's my workspace? 2.20523. Perfect. All right. So that means that we did it exactly right, which is handy. So a great way to check. And now you can check on yours too.